Okay, so welcome everybody. Today I'm going to be talking about introducing the idea of slope. And slope is one way in which we actually look at a line. It's a very, very important topic. We actually use it in things other than lines as well as we get later on in mathematics. But really, the idea of slope is a way to be able to measure the steepness of a line in regards to how steep a line is. And I'm going to talk about the words rise and run. So I'm going to simply begin by just defining slope as the vertical rise over the horizontal run. And so as you see here, the rise is associated with the y-axis. And so I'm going to go ahead and put the rise on top in the numerator. That's going to be the rise. The run value is associated with the x, that's the horizontal axis, and that is going to be the run. Now, in mathematics, we can actually change slope. We use a letter to represent it, so we don't have to write the word slope all the time. Many times we use the letter m for this, so I'm going to go ahead and write m is equal to. Now, there's also another notation that we use for rise. The rise literally means how much does the line actually change. And if we're looking at the y-axis, we can actually talk about this as being the change in y. In other words, how much does the y go up or down? And we're going to use the Greek letter delta. So this little triangle here is going to be a delta y. The run can also be written as also the change in x, and therefore I'm going to use a delta x on that. So I'm going to introduce maybe some new notation. I'm not sure if you've seen this before, but if I'm given actually 2 points here, I can actually write this out. If I'm given 2 points, I can just label the first point as x1, y1, and the second point as x2, y2. And if we label these as such, I can convert this over and give us a formula for slope. So in other words, m is going to equal the slope is going to be the change in y over the change in x. And so I'm going to begin by putting a subtraction sign on both the numerator and the denominator. And to be able to find my change, my delta y, I'm simply going to take the second y and I'm going to subtract the first y. In other words, y2 minus y1. I'm also going to do this for the change in x. In other words, I'm going to take x2 and I'm going to subtract x1. This here is going to give me the formula for slope. Okay, so for my first example here, I actually want to be given a line that was actually drawn for me, and I want to be able to find the slope of this. The easiest way to be able to find the slope is to be able to find 2 points that are actually integer values. And so on my line here, I'm just going to go ahead and find a couple of points here. There's an integer value here. As I go up, I can find another integer value there. There are others as well that I can find, but these are the 2 that I'm going to find. They're quite close to each other. And what I would like to do is I would like to measure this line. So I'd like to measure this line by finding both the rise and the run. Now you're going to see how much to travel from one point to the next. The question is, how much do I rise? How much does the y change? And how much does the run change, my x values? And so I'm going to go ahead and draw a triangle that goes up and over. And you will see here, if I calculate this, that the rise is going to increase by 2 spaces. There is 2 there. And my run here is going to change by 1, 2, 3 spaces. And therefore, I could calculate my slope of this line as being the rise, the change in y, all over the run, the change in x. Therefore, the slope of this line is 2/3. Now you might ask yourself, well, maybe you didn't choose those exact same points that I had. Maybe you choose some points elsewhere. And it doesn't matter because the line has a constant, what we call a constant slope. The slope doesn't change over time. And so you can go ahead and pick any points that you want. I'm going to pick a point here. There's a good integer point right there. As I travel up this line, let's say I go all the way to this point here. There's another line. And I can go ahead and do this. If I want to do the triangle even on the bottom, I can. I can go over this way and I can go this way. It's always easiest if you stay on integer values. If I calculate my rise here, I would calculate that it went up 1, 2, 3, 4. That was a change in y. That was an increase of 4. And my run here, I'm going to calculate it 1, 2, 3, 4, 5, 6. That's going to be a run of 6. And so once again, if I calculate this slope, the slope being the rise over the run, I'm going to put the 4 all divided by 6. And hopefully you recognize that 4 over 6 is actually equal to 2 over 3. Those are the same values, okay? 2 over 3 has just simply been reduced, but it doesn't matter whether or not I use a big triangle or a little triangle. I can go ahead and find the slope of this line graphically. Okay, so the second scenario in which you might be asked to find slope is if given actually 2 points. And so here I've been given 2 points. These 2 points are on a line, and so I can go ahead and actually calculate the slope here. I'm going to go ahead and use our formula. Once again, our formula is the slope is equal to rise over run. And so I'm going to go ahead and begin here by writing my m equals and my fraction bar, because the slope is always a ratio of rise over run. And so I'm going to go ahead and begin by putting my minus in my minus. I know that I'm going to subtract the y's in the top and then subtract the x's in the denominator. So when I subtract the y's, I'm going to go ahead and start with the 5, and it's really arbitrary the direction that you go, but I always like to start with the second value and subtract the first value. So I'm going to go ahead and put the 5 first, minus the 2. That's going to tell me how far did I travel. If you think about this, how far do you travel from 2 to 5? That's going to be 5 minus 2. That's going to give you a value of 3. Likewise, my run is going to be the change in my x. And therefore, I'm going to take the 6 and I'm going to subtract the 1. So I'm going to go ahead and put a 6 here and a 1 there. And once again, if you think about this, if you begin at 1 and you end at 6, you're going to have a distance of 5. And so when I go ahead and reduce this down, when I evaluate each one of these, 5 minus 2 is 3, and 6 minus 1 is 5. And therefore, you can calculate the slope of this line. By given 2 points, the slope would be 3/5. Okay, the last example that I want to do here for you on this introduction of slope is when you're given a table of values. So this is linear. I'm just going to tell you right away that this is linear. So all of these points are collinear points. They're all on one line. And so I want to talk about how we could actually calculate the slope here by given a table of values. So the first thing we want to determine is how much are we rising each time. Remember the rise is associated with the y value. And so I'm going to go from one point to the next point, and I'm going to say here from 10 to 15, I'm going to have an increase of positive 5. I can check that again from 15 to 20, and I'm also going to have a rise of 5. And I could do it one more time if you'd like, also a rise of 5. So this here, every single time, I am rising 5. When I look at my run, remember the run is associated with the x value here. And so what I want to do with that is I want to change I want to see how much I'm going to change every time the x value changes. And so as I go from 2 to 4, I have an increase of 2. And from 4 to 6, I also have an increase of 2. And one more time, from 6 to 8, I'm also going to have an increase of 2. Therefore, I can go ahead and calculate the slope of this by once again talking about my rise over my run. And since I have a constant rise of 5, I can go ahead and put 5 in the numerator. And my run is a 2. And therefore, the slope of this line, given a table of values, would be 5 over 2. Now you'll notice that all of these examples that I've given you right off the bat are positive slopes. We can also talk about negative slopes. In my next video, I'm going to talk about a little more complicated examples, and I also want to distinguish between how do you find out whether or not something has a positive slope versus how something has a negative slope. So go ahead and tune in. I hope you have a great day.